Good afternoon, Professor.
Good afternoon. So, Mehmet is also there, Aktash.
I'm sorry?
Hello.
Yes, I am here, Sanjay. How
Okay,
are
you are
you?
welcome.
Hello, Professor.
Okay. So, how are you with me in my chair?
Fine, thank you. And you, sir?
So, moderator is also there. Andrea returned back.
Sorry? Can you repeat, please?
Yeah, I say that moderator is also back right now, right?
Yes, I'm
So,
here, ready to help.
my chair, how many papers, how many authors are present?
That is me, Professor. And let me check here.
Mehmet Aktash is there, second.
Yes.
Mm-hmm.
Yes, we have 4 paper in this session. One is mine. That is the second one, right? For the
Mm-hmm.
third one,
PDSDP 2.
to Gloria.
Ithmir is there.
The first
Gloria.
one, yeah.
Avda. I hope that he is also there. hmm I think the third one will also come.
Okay.
hmm Because I will call him because he is in already in the Nigeria. Okay. Mm. And then let us start.
Okay, let's start.
Rosaline is there. Back. Welcome back, Rosaline. Who else? Okay, so it's okay.
It's okay.
Start. I think so.
Okay, Professor, I'm going to start.
Mm.
I'll play a video from my colleague. He want to explain his paper, so I asked him to make a video, and I'm going to present now. Just I'm sharing my
Okay,
screen.
okay, it's okay. hmm
Okay, everybody see my presentation? We're gonna play, right?
Okay. Yes. He said that he didn't find the screen. Okay. You have anybody who can fix something? A reasonable guy, like this car man.
We have somebody.
Hmm?
I'm going to Yano. I'll just ask them.
When?
I'm going now.
Take it.
I'll just...
You know two problems. One is software. I think he has installed the software or not.
I don't know.
Okay.
But if he did, he would have asked you to pay something. Definitely. Definitely you go and check them. Okay. All right, sir.
Yes, sir.
Okay, so I'm going to play the video, right?
A while ago, I was at the beach. How I missed that. Talking with a friend about this work. Actually, it was in a very initial phase. And I was talking about how challenging it is to work with microservices in a large and distributed system, such as an electronic medical record system. Like me, this friend works for a bank in the IT department and promptly came up with the idea of using service mesh to address most of the issues that I was concerned about. He told me, I quote, "Microservices are easy to deploy but hard to manage." He was right. Today, the architectural style of microservices is widely adopted in the design, development, and delivery of software services and distributed applications. Proof of that is its adoption by major global companies in the development of the web applications like Uber, Netflix, Amazon, banks such as the one my friend worked for, and several others. Among the issues concerning deploying a system based on microservices, ensure a satisfactory level of observability is one of the most challenging. By an observable system, we mean the administrator has the means to understand and monitor all the operations in the system. A clear example of these challenges is the monitoring of transactions that represent a single context, but that are carried out through several microservices, spreading log information, make the tracking of its distributed execution not trivial task. The Six Saúde project has been developing a software platform for the management of health data through an electronic medical record in the context of clinical schools at the Federal University of Rio Grande do Norte. The system is currently running in more than 20 school clinics for a variety of medical specialties. By nature, current health systems, especially those based on electronic medical records, are designed in a distributed fashion, take advantage of enables technologies such as cloud computing, mobile, and microservices. Due to the number of users and players involved for these systems, it is all about scale. So what we have done in this work? First of all, we have evaluated the different service mesh solutions. We have listed and documented the requirements related to all the questions of observability for the Six Saúde system. We have proposed a service mesh solution that can be integrated in the Six Saúde system under development and carry out with a pilot of a proposed solution in order to highlight its gain limitations for the Six Saúde platform. From the Six Saúde's operation point of view, what is important to observe? Metrics related to execution time of reach request, request success rate metrics, traceability in the flows of requests, request size metrics, centralized handling of logs for problem debugs, because all the microservices will create their own logs, and we need to centralize that somehow. Alerts related to the average requested time. When the time of requests has become too high, we must to receive some alerts. Alerts reporting degradation or failure in microservices, because we need to know, we must to know when a microservice goes down. And finally, alerts related to host memory usage, because we must take care of our infrastructure. This figure illustrates the mesh service architecture deployed or suggested for the SigSaúde platform. After evaluating some mesh services implementations, such as Istio, Linkerd, Council, and many others, we have decided to use the Istio. Istio enables basically to create a network of deployed services with many handful features such as load balancing, service-to-service authentication, monitoring, and many more. But the special feature is we can do all this stuff with few or none code changes in the service code. That feature was decisive for our choice of using Istio. In Istio architecture, sidecars intercept all incoming and outgoing traffic from the microservices and communicate with the control plane services. It makes possible to send metrics and data for all available microservices, regardless the quantity or distribution of containers. So it's very scalable. This data is sent to the mixer component, which is responsible for passing on to the tools incorporated into its pluggable backends, because we can plug in some applications to make use of this information. This component will be actually the mixer responsible for gathering all the information needed for observability of the system. For example, in our work, it's used. We use the Grafana to monitoring the running services. In order to test our implementation, we have conducted some tests to generate service-to-service communication in the system. Briefly, we have injected HTTP requests to simulate a few usage operations of SigSaúde users. Distributed tracking allows users to track a request through the mesh distributed across various services. For this purpose, we have used the Jagger tool, as shown in the figure, installed by default by Istio. This tool enables to get metrics related to the execution time of each request, the request success rate, and the traceability in the flow request. It's possible to follow the service mesh at runtime by using the Kiali tool. Kiali is a powerful and open source visualization panel that comes by default with the Istio. The figure shows the real-time graphic generated by the SigSaúde system. It displays visual indication of the overall integrity of the application running. One additional requirement for the SigSaúde system was to enable alerts related to the host memory usage, as it will impact the overall performance of the system. Unfortunately, the Istio does not yet allow alerts within the scope of the service mesh. To overcome that, we have used the OpenShift OKG. The figure shows the OpenShift web console, which is possible to view system information from the point of view of the cluster administration and not of the hosted applications. Well, as conclusions, we have found that the proposed architecture increased the level of observability of the six-hour system by providing integrated tools to monitor the microservices. The proposed solution is scalable, allowing to monitor the growth of the platform infrastructure. And finally, we have met all the 6 hour observability requirements without requiring any change in the code or the communication of the microservices already implemented
by the team. So that's it. Thank you very much. Any question? Or listen to me? Professor, I guess you're muted.
No, what is the major contribution in the work if you compare with others?
Yes, in fact, the main contribution of this paper is to obtain the observability requirements, non-functional requirements, without changing the code, because use a set of powerful tools that can monitor the telemetry of the system, the time that each microservice are communicating and everything, and present alerts about it, present some graphs that we can improve the application. So it's a set of tools that we can put to attend the requirements related to non-functional requirements and observability.
No, but how are you discriminating it that this is really different than the others?
Because this one we put under.
Yes, I'm in ICCA conference, please.
This one is a new concern, because what we have today is a set of the architectures of today. They are defragmented and decentralized, and then with this tool, that is the Kiali tool, all those things together, we can provide this kind of requirements. So that's the main difference between the previous solutions. We integrate everything in a panel using many other tools to provide the observability. This is a common problem when we have some systems that we require to be always on. They have to be they need to have observability. They need to be open. They need to be on, attending all the requests. It's common used in banks, health services, or things like that. So
you are targeting the non-functional requirement, and you are targeting the observability as a non-functional, one of the attribute of the non-functional requirement, right?
Yes.
Yes. So, and you have, I think you are using some ellipse or something to attach your tool and take some of the observations, right?
Yes, we have some tools. We have some tools to present the results of all this telemetry. And one of those is the last graphic that I've shown here, which is the Grafana. They present all the metrics, all the time, everything about the microservices.
Okay, so thank you very much for me. It is a very interesting lecture because you was working in medical informatics and now you are in core requirement engineering topic. In fact, it's okay. It is very nice to see your work, and we are also working on this area, so it is a good platform. Yes, Mehmet, have you any question?
No, I don't have any questions at this point.
You are also from software engineering, so you may have.
No, it's for this presentation, I don't have any question.
Okay.
Okay,
So
thank
I
you.
think you can present.
Thank you very much, Professor. The next one is Gloria.
Okay.
Is Gloria present?
The paper is a path for implementation of best practice for software requirements management process. About the third one, proposed facial image quality assessment. Or not.
The third paper belongs to you, Sanjay.
Yes. It is your TDD SCP2. Gloria is, where is the Gloria is?
Any other presenter for the session?
Mehmet is there. Mehmet is going to present now.
I can take the turn if that's okay.
Okay.
Okay. Okay, should I present it or should I wait for the other authors?
I think you can present.
No, present.
Okay,
Present.
so let me do the screen share then. So hold on. So I'll do the entire. So I'll do the application window. Hold on. Okay. Give me 1 second. Okay. All right. Now, what I need to do? Yeah, there it is. Share. Okay. Do you see my PowerPoint on your screen?
Yes.
Okay. Okay, I'll just start then. Now this, so my name is Mehmet Aklas. So I'm a professor at Yıldız Technical University. And the paper that I'm going to presenting is a joint research between FIBA Banka, which is a corporate banking company in Istanbul, in Turkey, and Yıldız Technical University. And in particular, in this research, what we did is we designed and developed a software architecture that can manage machine learning models designed for churn analysis and customer retention. Okay, so what I will be doing is that I will be discussing a software architecture, and then I will talk about the prototype and its evaluation. Okay, so what motivated us to design and build this software architecture? Okay, now, so in this particular work, what we are trying to do, we are trying to do churn analysis, customer churn analysis. So this term is also called customer attrition analysis. And also, in addition to that, we want to do customer retention analysis. So first, I need to explain what these terms are before I go to the motivations. So customer churn analysis or attrition analysis is a type of analysis that is used to predict the probability of losing a customer. So you do this analysis in order to find out whether your customer is going to leave the system. Okay. Now the second motivation that we are after is the retention analysis. And the customer retention analysis is a type of analysis which is used to predict or which is used to recommend services or products to customers so that you can increase their satisfaction in customer experience and hope that they will stay in the system. So you do the churn analysis, you identify the people who are likely to leave the system, and then you want to run the customer retention analysis and find out what kind of product that you can recommend to the right person at the right time. Okay. Now we do these two different analysis on an interaction data set between the customers and the banking company. And in this particular work, so we investigated whether or not we can generate a generic software architecture which is independent from the machine learning algorithm implementations that can manage the models which are created for churn analysis and customer retention analysis. Okay. And to do this, we identified several research questions. So first off, here, so we are interested in, hello?
Hello, good afternoon.
Who is the survey?
So
Hello, yes, continue.
Okay, I'm going to continue. So
yeah, continue.
Now,
this survey?
The first question is, so what are the models, machine learning models that are needed in order to analyze such a data set in order to predict the customer's behavior? Okay, and these models are both supervised and unsupervised models. First off, we need to identify these models. The second thing is that how could you come up with a generic and hybrid model management software architecture? Generic in the sense that the implementation of the model management architecture should be independent from the subsystems. So if one of the subsystems change its implementation, we should not be changing the model management software implementation. Okay. And the third question was that if you come up such a generic architecture, how would you go ahead and evaluate such an architecture? So how would you go about evaluating such an architecture? What would be your testing strategy? And so after investigating this, then using such an evaluation strategy, how does the proposed system that we are proposing here perform under this evaluation strategy? These were the research questions that we identified at the beginning of this study. Now, at the screen right now, what you see is a data pipeline that I want to show you before I show you the design of the architecture. As you see here, there are two segments in this data pipeline. Now, the first segment, the upper segment, is interested in doing the churn analysis on the data set. Okay. And the segment below is interested in doing the retention analysis on the data set. Okay. Now let's look at the upper segment. As you see, we are interested in the customer and the banking interaction data. So all the interactions that the customer is doing with the bank. So we are collecting that data from the log files, also from the bank database. And we do the feature extraction. We extract behavioral features, temporal features, the features related with the customers that the bank company is keeping, okay? And from this, for each of the user, so we create feature vectors Okay, and these feature vectors, when you put them together, then you come up with a future matrix, and we call this behavior future matrix. And this is the data set which is then is going to be pushed into a pipeline which is going to generate model, supervised learning model. Okay, I will show you that slice in a second. Now look at the segment below, which is interested in doing the customer retention analysis. Okay, now here you see that we have on the transaction data, so we are creating two different matrices. One is the user item matrix dataset construction. So we are creating a user item matrix. And in addition, what we are doing, we are creating transaction dataset. Okay. Now these two different datasets are for two different purposes. One of them is going to be used for content filtering or collaborative filtering based recommendations. The second one is going to be used for association rule mining based recommendations. Okay. Now, as you see, the segment below is using unsupervised learning models where you don't have to have the labeled data, and the segment above is related with the customer attrition or customer churn analysis. So therefore, for those that kind of data analysis, you need the labeled data. Okay. Now, after the data sets are created either for supervised machine learning or unsupervised machine learning, and such data sets are then pushed into model creation stage of the pipeline. Now, the picture that you see on the screen is basically based on a Lambda architecture. Okay, so Lambda architecture is a known architecture type where you can do batch processing analysis and also the streaming processing on the data. Okay, now here simply what we are doing is that after the data is pushed into the model creation stage, as you see in the picture, we are creating models either for supervised learning models or unsupervised learning model. Okay, now the supervised learning models are being used in order to predict whether or not a customer is going to leave the system. Okay, this is for churn analysis prediction. Okay, now the unsupervised learning models are being used for recommendation. Okay, for example, in this slide, you only see association rule mining based recommendation here. So, for example, the model which the association rule mining is going to produce is the set of rules, actually, set of rules. And based on those set of rules, you'll decide which customer is going to be recommended what. Okay. Now, this is the data pipeline. Now, the idea was when we initiated this research, we said that what we want to do, since we have to do these machine learning data pipelines on the data sets that we gather from the customers, and the libraries, the machine learning libraries that we use differ from each other because some libraries perform better than the other ones, even though they implement the same algorithms. For example, Spark ML library implements these algorithms with MapReduce framework. So therefore, if you have a large set of data, it makes sense to use Spark ML library. And some are implemented as if all the data will be sitting on a single node. So therefore, those libraries will perform better if you have all your data on a single node. Okay, and some libraries have much more algorithms implemented in it compared to the other ones. And also, we realized that in time, these libraries create their newer versions written in different programming languages. So therefore, so we said that we don't want our model management system to change every time the subsystems change. So therefore, we wanted to come up with a software architecture that provides independence from the subsystems being used. Okay. Now look at this picture that I'm showing to you. This picture shows you the abstract software layers. Now in the rectangle shape in the middle is the system that we are proposing, and the system is being interacting with the client applications on top, and the system is interacting with the subsystems, which are the implementation of different machine learning libraries and implementations of different storage mechanisms, either the persistent storages or the in-memory storages. Okay. Now I will go into the this abstract software layer in the next picture. Okay. Now, as you see, so this is as if you are focusing in within that rectangle, so that you can see the inside modules inside of that the big rectangle which was in the middle. Okay. Now, so look at. I'm going to go through these layers from top to bottom. Now, as you see at the higher level, at the top level, so we have the RESTful web service interfaces, which allows client applications to interact with the system. Okay, so you have different interactions. So the client applications can do data pre-processing. They can manage these models. They can, by saying the management of the models, what I mean is that they can save these models into physical hard drive. They can restore it. So they can just delete it. They can initiate creation of the model again. So there are different functionalities. And so you can interact for product recommendation. Okay, you can interact with them in order to find what is your next best action. Okay, because we are also doing sequential rule mining on top of the data set. Okay, and you can monitor existing models. You can ask questions how many times that these models have been used. Okay, how successful that each model are. Okay, now these are the request layer. Okay, now the next layer, the layer below that, is the request processing layer. Okay, now as you see, we have different modules for different purposes. So each module is responsible for handling the incoming requests from the client applications. Data processing module, model training management module, which is responsible for basically creating a model and training the model. Okay, product recommendation model, churn prediction module, etc. Okay. Now, a layer below that, you see all the models which are being created by the system. Okay, and as you see that some of the models are supervised model. Okay, and some of the models are unsupervised models. Okay, so when I say unsupervised model, so what I mean is that, for example, if you consider an association rule mining, okay, so this is an unsupervised machine learning methodology, and the result of the association rule mining algorithms is generating a set of rules. Okay, these set of rules, what we call this as a unsupervised learning model. Okay, so for example, just think of collaborative filtering. Okay, collaborative filtering is also an unsupervised recommendation algorithm, a well-known algorithm. Okay, and in order to do the collaboration filtering, what you need to do, you need to create a user item matrix, and obviously there are lots of unknown values in such a matrix, so you need to fill those matrices in a way that if a question is being asked to the matrix, so you can answer it. So therefore, so we have both unsupervised learning models and supervised models within the system being managed. Now, if you go one layer below, you see resource managers, and these are the resource managers that manage the underlying subsystems, okay, without knowing their implementations. So what does this mean? For example, so here you see that recommender model management module. Okay. Now, this recommender model management module knows that there exists a subsystem, okay, for collaborative filtering or content filtering, okay, and the path to this machine learning library under the file system is such and such, okay, and under the machine learning library, it also identifies the path to the class, okay, in which the collaborative filtering algorithm is implemented. So these resource managers are interacting with the mapping rule files, which are basically telling the system that we are implementing where the subsystems are located in the file system, and so where the classes that implements the corresponding algorithm in the library itself. Okay, so therefore the resource managers are not actually the modules that are running the algorithms themselves, but they are utilizing these subsystems in order to execute the algorithms. Okay, so you see that we have the facade layer, which allows us this to do this separation. Okay, now you also see that, so we have persistent storages and in-memory storages. Obviously, we did not want the system to be dependent on the storage systems that that are being used. So in time, these storage systems can change. Therefore, we wanted to also interact with these systems through the facade design pattern. Okay. Now, after that, we wanted to evaluate such an architecture. So we designed it in such a way that we claim that now this kind of implementation will not be dependent on the implementation of the subsystems. Okay, how do you go about evaluating it? So we said that first of all, we are introducing here a facade design pattern for model management. Okay. So, and by the way, so we looked at the papers and also the open source tools, and we haven't encountered such a generic model management infrastructures that we can use. That was the motivation for us to come up with this. Okay, and then we said that okay, so the facade design pattern will introduce here an additional overhead. So what it would be interesting to find out if this overhead is negligible. Okay, is it okay to use this facade pattern without losing too much computation time? Okay, and then we did an experimental study for changing data sizes that we use for training. Okay, and so we use obviously different algorithms from different libraries, and we run the test for the back end. Okay, when the system is using the subsystem without the use of facade design pattern, and with the facade design pattern. Okay, and as you see, the two figures are so the first one belongs to the first algorithm, first supervised learning algorithm from one library. The second one belongs to another supervised learning algorithm from another library. As you see that the performance overhead that comes with the facade design pattern is negligible. Okay, the advantage that we gain out of such an generic and hybrid software architecture, which is much more valuable compared to the performance loss that we have, because the performance loss that we are talking here is negligible. Okay. Now, in conclusion, what we are producing here, so what we are proposing here, we are proposing that machine learning models can be managed by utilizing a generic software architecture. Okay, and so you can do churn analysis and also the retention analysis on any types of data. In this particular case, we were interested in the banking customer banking company interaction data, but you can use this idea on other data sets as well, especially for telcos sector. Okay, and such data analysis pipeline can be managed by the model management, generic model management architecture that we are proposing here. Okay, and we also implemented a prototype of this a simple prototype of the proposed architecture, and we evaluated this proposed architecture to test its usability. And the result that we gained showed that the system is producing a negligible overheads. So therefore, we claim that it is usable for those who are interested in data analysis, which needs to be repeatedly done. Okay. Now, this is the basically the work that I wanted to present to you. Thank you for listening.
Thank you. It was a very lengthy presentation.
Sure, thank you.
A lot of time. It's
I'm
good.
sorry. Yeah, so it seems
Yes, it's good. Any question, please?
Yeah.
If any question, please. Any question? Yes. So, Mehmet, just to summarize, means what are the major findings of your works which discriminate that your means work is novel than others?
Okay. So the existing data processing pipelines are our finding is that existing data processing pipelines are highly dependent on the machine learning libraries that they use. Okay, if and when the underlying machine library need to be changed, basically the implementation of the whole pipeline gets affected by that. Okay, so therefore, what we want to do, we want to introduce a middle layer in there, so that if you want to use all these models based on the machine learning library, you can use the machine learning library that you want, but use this middleware, this generic software that we are introducing, so that later on, if you want to change the underlying subsystem, you can do that. And frankly, so when we looked at the open source tools and also the literature, so we couldn't find such a generic model management architecture. So we claim that the idea here is unique.
It's okay. Thank you so much. It was a novel work, and I highly appreciate your and your team who has done this job. Any other question? In absence of any other question, I invite to the next presenter. Who is on the next presenter is Adebayo Abayomi Ali, proposed facial image quality assessment. Are you there? Yes, we can't hear you. We can't hear you.
Okay, I am here. Good afternoon.
Yeah, it's okay. Good afternoon. Share your screen and present your paper. You know how to share, right? Left hand side.
Yes.
Please, yes. Go ahead.
Can you see my screen now?
No.
Okay. Can you see my screen now?
Yes.
No. Is it shared? Yes, now.
Oh, okay. Okay. So,
Go ahead.
To all the participants, so assessment using an example of learning models. So we call the model EFQNet. So it's actually the research or the proposed study is actually by myself, Abayomi Ali Adebayo, Olabode Atinuke, Onoshoga Saidat, Mr. Sanjay Arundade OT, and the Abayomi Ali Olushola. So actually, I'm supposed to be presenting with Atinuke Olabode, but she's about to come online now. So I might probably hand over to her. That you oblige us to do that. So this is the presentation outline, and then I'll just go straight into it. So face recognition is an important research discipline, and it cut across different areas. And then the human face is a vital biometric sample in contrast to other biometric systems like fingerprint, signature, gait, and several others. So we have seen from research literature that digital images can be obtained from diverse sources and compressed using various communication. The facial recognition systems is the usage of low quality facial results in low recognition accuracy of face recognition systems. So once the quality of an image has been assessed, pre-processing methods are applied to improve image quality to keep the best image as the of the probe image. Image quality assessment becomes a crucial step to be performed in order to ensure the accuracy of image processing system. And then the performance of such face recognition system is influenced by different variabilities. Difference in the lightning, the sharpness, illumination, background, pose, and so on. Because most facial recognition systems operate in surveillance scenario or uncontrolled environment. So there's always a lot of variability that affects the quality of the different facial expression. So there is a major difference between universal image quality assessment. The universal quality assessment deals with the quality of images, whether it contains faces or not. However, facial image quality assessment deals with the quality of face in that particular image. So we have said that the efficiency and recognition accuracy of facial recognition system depends on when we use high quality facial images, then you are very likely to end up with a high recognition system. So the most widely used research method for image quality assessment is to compare the peak reference image and a probe image that has some distortion or that has a low quality. So image quality assessment involves comparison between a reference image and a probe image. The reference image, in this case, you have what you call a full reference assessment. That is, when you are comparing, you are making a comparison between a reference image, which is a very good high quality image, and a probe image, which is the low quality image. Other methods that do not require the knowledge of original images is known as what you call the referenceless, the no reference, or blind reference assessment. You have what you also call the reduced reference assessment, which gives partial information about the original image. So image quality assessment is carried out using two approaches. You have the subjective and the objective assessment. The subjective assessment employs evaluation scores based on human perception, where you now have an average or the mean of the opinion of the experts. So the subjective scores for several aspects of the image. However, the other approach is the objective quality assessment. Objective quality assessment employs mathematical algorithms and models to analyze and determine image quality without any form of human perception or opinion. So, studies that have been referenced in facial image quality assessment systems using blind reference 14 pioneered the use of deep learning techniques in the quality assessment of 3D images using the Q3D RBM approach. Live in 2015 showed that deep learning can extract meaningful features from images better than traditional machine learning algorithms, leading to improved prediction accuracy. Subsequent studies on deep learning approaches to facial image quality assessment includes the one referenced in 2, 3, 4, 6, 7, 17, and 18. So this table shows the review of the related works in this proposed study. So I want to hand over now to my co-author, Atinuke Olabode, who is presently online, so that she can continue from here. Thank you.
Continue. Is she online?
Yes. So yes, she's online now. Atinuke.
Ajinuke.
Atinuke, can you share your slide now?
Where is she?
Okay. Let me, sorry, maybe I'll have to continue. I'm sorry. She just texted me and said she's online now. Okay, so our research approach is we are developing a facial image quality assessment system using pre-trained CNN models, and then the facial image quality assessment system is named EFQNet and is a no reference image quality assessment. No reference, as we have said, is you don't actually require the knowledge of the gallery image in order to make a prediction of the quality of the image. That is, just having a probe image is enough for you. So we are going to be using an example of ResNet, DeskNet, and InceptionNet pre-trained models. So now the system is going to first of all use what you call a ground truth to forecast the numeric quality of images between the scores or between the range of 0s and 1. So the data acquisition or the data set you are going to use is obtained from the VGG phase 2 and the BioSecure multimodal database. So like from literatures of, we have seen that VGG phase 2 database is used for training the quality assurance network and then the EFQNet models, while the BioSecure multimodal database will be used for evaluating the image quality assessment model. So the VGG phase 2 contains about 3.31 million images with 9,131 different subjects. It's actually images of well-known celebrities that is taken or captured in various unconstrained environments. That is to mimic reduction or variation in quality, such as in pose, expression, age, illumination, and so on and so forth. So the data acquisition, the biomodal database consists of 600 subjects with images acquired in 3 different scenarios. We have images acquired from a webcam, mugshot images from a high quality camera, and then indoor and outdoor images with mobile and digital cameras. The database is divided into 3 equal subclasses based on the quality of the images, the highest quality, the medium, and then lowest quality images. Now, for the ground truth generation, we are using the ICAO compliance software deployed on 500 subjects, which were extracted from the PGG phase 2 database. The Biolab ICAO compliance framework was used to obtain the compliance, and then the framework output is scored between 0 to 1 and 0 to 100 for each ICAO compliance test on the image. Then the ICAO compliance software helps to determine the reference image of a particular subject. That is the image that we are going to be using as probe. Okay. So the other images of the subject are compared with the reference images through future vectors extracted from the pre-trained FaceNet model. Now, for the ground truth generation, the quality score of an image is obtained when the future vector of that image is compared with that of the reference image. So equation 1 shows the Euclidean distance measure between the gallery image, which is the high quality image, and then the probe image, which is the reference image. So D of P and Q is what gives us the Euclidean distance, that is the disparity or the similarity between the two images, where the 2 points P and Q represent pixel points in 2-dimensional Euclidean spaces with the coordinates P1 of P1, P2, and Q1, Q2, respectively. So the similarity score is in the range of 0 to 1, as we have said, based on the ground truth generation, representing quality between the low quality to the highest quality. So with what we have, you have the VGG phase 2 database, and then you have phases going into the ICAO compliance software, and then images with the highest quality goes into the FaceNet, and then the future vector is developed, and then the other images of that same subject is now compared. Then you now get the distance measure between the future vector of the high quality image and the future vector of all the other images, all the low quality images of that subject, and then a ground truth generation is obtained to develop to predict the quality of that image. Now, we are going to be using, like we have said, we are going to be using an ensemble of 3 pre-trained deep learning models. We know that deep learning, transfer learning is a method in deep learning where previously trained models for certain tasks are reused, okay, to carry out similar tasks or in related tasks to boost their performance. Because those models have been trained on very large data sets before, it makes it easier for them to be reused or to be adopted such large quantity of data. So in this study, an ensemble facial image quality assessment will be done using 3 pre-trained deep learning models, which are ResNet, GuessNet, and InceptionNet. Okay, so the ensemble approach is proposed to ensure an accurate facial image quality prediction in an uncontrolled scenario. The architecture of the EFQNet is presented in figure 2, and then the pre-trained models are discussed in the subsection below. You have one, the ResNet. The ResNet network contains multiple residual blocks stacked over each other, and each of the blocks contains several layers. So this is the architecture of the ResNet. This is the address architecture. So I want to go back to the entire architecture of our EFQNet. So this is how our EFQNet looks like. You have the trained database, which contains the face images and the previously collected values. So it goes into our ensemble model. Our ensemble model contains our ResNet, the DeskNet, and the InceptionNet, which is now concatenated together through a feedback mechanism and a signal approach to give us the quality score of the probe image. Like we have said, this approach is using a no reference image quality assessment. So this slide is just giving us some of the features of the pre-trained models, that is ResNet. It includes 2 convolutional layers, and each of them has batch normalization and relox activation function. Then it contains skip connection that bypasses the convolutional layer, and then it is added back to the final activation function. Then the DexNet is similar to the ResNet. The only difference is that the output is concatenated by introducing connections from each layer to other layers. So this is the architecture of ResNet, this is that of DexNet, and then Inception Net. So this is the architecture of our Inception Net. So now this is the algorithm for the ensemble model training. So for airport I of 1 to n, we are going to be training the models for k of 1 to of 1 to m, that is the number of probe images for that particular subject. So we obtain the 4 set of features from ResNet, the set of features for DexNet, the set of features for InceptionNet. Then we have a function to concatenate or match the 3 features together, then which is now passed through the feed forward function, and then the quality score is obtained using the sigmoid function. Then we compute the loss function L. The loss function L is computed using the graded function, and the Amgrad gradient function for our loss function. So the Amgrad optimization function is a variant of the Adams optimization algorithm. So it actually modifies the learning rate and ensures that the current V is always larger than the previous V in the time step. So actually the Amgrad makes use of what you call the exponential moving average. So this is the algorithm of the Amgrad approach, which we are using for optimization of our concatenation and assemble of our algorithms. So it actually makes use of a moving average, which is based on the V, but it ensures that for every optimization cycle, the value of V is always higher than the previous one in the next time step. So in doing that, it actually updates the model parameters. So now, after obtaining the quality scores, okay, for each of the probe images for the over 500 subjects, we intend, our plan is to deploy the model or the result of the model in what you call a facial image personal identity verification scenario. An example, like from literatures, we know that facial recognition can be is in identification scenario, and another scenario is in authentication scenario. So in this case, we are going to be deploying our model for authentication scenario, or what you call personal identity verification. An example of that is in the use of maybe an ATM, for example, where the user
Dr. Ali, you have only 2 or 3 minutes more, okay? You have spent a lot of time. Hello? So I think in absence of the connection out. Hello, can you
He
hear me?
probably lost connection. Yes.
I think some of them, one doctor, Arvind is on the online. He missed one of the paper since from the morning session. I think we can ask him to present, right? What do you think?
Sure.
Yes, it's
Sure.
for sure. If he is present, no problem.
Armin is present, yes. Yes, we can. Yeah, Armin, please go ahead and start your presentation. Good evening. Who is on the line? Yeah, Manuel. Which message? No, I have not. It is a WhatsApp message or text message. No. When should I come now? Or maybe tomorrow is possible because I'm busy in my conference. Okay, I will try my best. Okay. Thank you. In VC office, right? It's okay, but thank you. Sorry, I'm busy in fact in the conference. Thank you. Yes, I think he is out, and we have also spent a lot of time. Mr. Armendra, are you ready? Please share your screen. You can present now. Hello. Hello. Hello.
Sir, you should unmute yourself.
Okay.
I mean, Mr. Amaranda,
Uh-huh.
he should unmute himself by clicking on the microphone. No, he lost connection.
Yeah, he disconnected. Yes.
Yeah. Is any other presenter here in the room?
I think from this session, nobody.
Okay.
We have one more presentation, but I don't know this guy from the Korea. He is present. I'm going to write a email. Is he back? Is he available?
I don't think so, Professor.
And Ali is also not back.
We can proceed
Hello?
with the question.
Hello?
Hello, proceed with the question.
I actually went off, so I don't know where I lost you guys.
Because your connection is not very good.
Is it my connection?
Yes, of course, everybody is waiting for you. That's why I suggested that, okay, why not this paper is presented by Mrs. Olusola from the Europe. She has a very good connection there. Hello? Hello? Chair.
Lost connection again?
Yes, I guess. So if
I didn't know.
Okay.
He's trying to come back.
Yeah. So if there isn't anyone that could present for this section, can we go to the next one? TTS-PP3.
I think so.
Hello? Hello?
Yes? Yes.
Okay. I don't know why it keeps logging off. Okay.
Oh,
So
leave it now. I think you have to end it. So we have TDSTP3 as well. There are 3 presenters here in this TDSDP2. One is absent, right? One is absent. Gloria is absent. Gloria. And then TDSDP3, right? SDP3. Is the Jao, is Silva is present? From the next, it is already 5:30, right?
Yes, John Silva is presented. Is present. There is 2 other one. C40 and Carl.
Yes, we same guys are here, but is any presenter available? Otherwise, we have to end the, because 5:30 session is also already started. And in the last session of the say TDSDP 3, I think nobody is there, right? TDSDP 3, nobody. TDSDP 2 is only one was absent. Hello.
Is anyone present for the last session?
Anybody is present?
No, I think that.
I doubt that anybody is present.
Yeah. Okay, Professor. I think you can end it now.
Hmm?
What about the picture, Professor? How are we gonna take the picture?
Yes, we can take it.
Yeah,
Ask everybody to
I have some picture. All the SEPA meetings.
ask everybody to on the camera.
Yeah, take a screenshot. I think I have with Jay also with you, sir.
Right?
Very nice.
Okay, so I think
Yeah,
Jai,
I think
Pancham
we
from
all
South
send
Africa.
our images to you and we just Photoshop it in.
No,
Yeah.
I think Mr. Arminder, can you present the paper now? We can't hear you. Please unmute your mic. Please unmute your mic. Your mic is muted, but I can see it here. We can't hear you. Present, otherwise tomorrow there is no any vacancy for any presentation. Program is very tight. Still, your mic is muted. I can see from here. Your Armind, your mic is muted. I can see from here. Itmir, I think your mic is also unmuted.
Mine is muted. Was
Okay,
muted.
it's okay. Yes. So Itmir, you can take a picture.
Okay.
Now everybody is with the camera.
Let me take this picture. So everybody could please open your camera first. Let me see how I can. Oh, nice. This is good. Here it is. Okay. I'm gonna send to you, Professor.
It's okay, it's okay, it's okay. Africa, Brazil, Europe, and even several places. South Africa, Pancham is representing that one. It's okay. So, Dr. Arminder, please, is it not possible for the presentation? I don't know what happening.
His mic is still muted.
No, it's
Yeah.
okay. Now we can hear you now.
He was telling that
No.
he has a problem with this microphone. With his microphone, I guess.
So, but we can hear now. We just heard his voice.
No, it was Jay.
No. That was probably me.
Yes.
Oh, that's probably you. Okay, I thought that it is an Indian voice. From where it is coming?
If you can share your slides with me, I can carry on. Maybe can you send him a message to enable his mic?
He has he can hear us.
Yeah, he told
Okay.
that he has a problem with his microphone. It's on the chat, I guess.
Fail to access microphone.
Yeah.
Because I can see his microphone is all the time it is muted.
Yes, it's actually muted. Maybe if it disconnects and connects again, might help.
We can restart.
Or change the browser, I guess, maybe. I don't know.
Could be an issue with the browser, yes. You can change the settings in the browser to allow microphone in the room.
Maybe, yeah, maybe close the browser and open it up again.
Yes, my last suggestion is because I don't know that he will be, Dr. Arvinder, you will be able to present tomorrow, just to present your slides. And I will request not from the conclusion, start from the abstract.
He's probably gone through the presentation, which we missed.
No, but we have not seen the slides. Yes.
Management. Information system resource training hospitals. Okay.
It's very funny. You are the dean of the office of the quality management, and there's no any quality management in the mic system of your system. No, just joking. Okay, please. It is possible with anybody. It can be happened with anybody. Yeah, it can be happened with anybody. And especially in Africa, internet is a very, very big issue. Anything can happen anytime. Yes, please present. Go from one by one slide, please. Dr. Arvinder, please go ahead.
Next slide. I think that he's having lots of issues, even with the presentation, I guess.
It looks like, okay, just to tick his presentation and evaluate whatever you can evaluate it, because we don't have the time for tomorrow, right? And tomorrow again you are coming back. So within 2 minutes, if it is not coming up, we will end the session. We are sitting since morning. It is now 7 hours.
Yeah.
I came at 8, it is 5. Hello?
It's connected, I think.
Hmm?
It is connected?
Yeah.
The challenges of this new age, right?
Indeed.
Connections and everything.
The second point is that if you are not using your laptop for the meetings and other things, and if you are coming suddenly, you will find that your laptop is not a very, so use only the very effective ones, which you have already, you had a meeting, you have presentation or something like that. Okay, I think we should thank everybody, and in absence of any of the other presentation, we will end this session at this time, right?
Sure. Thanks, Prof.
Anything you want to discuss? Anything? Thank you so much for presenting the authors who has presented, who was present. Also, all of us who are trying, but there are several of us, we also spend the time. Tomorrow morning with the same CET time at 8 a.m. in the morning, we are again starting. The sessions are tight. And
Sorry, at 8 or 9? Is it 8 or 9?
No, CET as 8. Oh, sorry,
Okay.
CET at 9, sorry.
9, yes. 9.
8, yeah, I'm sorry.
Yeah, okay. So, yeah, see,
Yeah,
it's the same as South Africa, so yeah, I'm lucky.
So you are at 9, okay, but I'm not lucky. And even though he's coming at 4 a.m.
Yes.
Oh,
So tomorrow you can have a few hours sleep.
No, he's coming. He's also coming in the morning.
Okay.
Yes.
I asked him to check the SEPA because it is good to evaluate all the papers by one person. So the evaluation should be done in a without any biasing. You understand?
Sure. Okay.
He's
That's fine.
evaluating all those papers. So
Okay. That's
so
fine. So he'll be here in the morning.
yeah, he will be in the morning. He will be all the SEPA sessions, maybe on third day as well. Fourth, so but he
Okay.
will also be here, okay? Just in case
Yes, I'll be here. Sure.
anywhere all
Yeah,
the
I'll
time,
be here.
okay? So
Sure. I'll be here.
thank you so much, Dr. Ali. Thank you, Dr. Mrs. Ali. Thank you as well. Okay, anybody else, Dr.
Thank you.
Ahmed? I'm sorry that we couldn't listen your presentation, and I don't know. It's okay. So, and finally, the moderator, he's also with us since morning. Thank you so much, Andrea.
thank you, sir.
Okay.
Thanks, Andrea.
See you tomorrow.
Okay, you will be the same guy here, right?
Yeah, for tomorrow and Friday as well.
On Friday. Saturday,
Yeah.
who will be here?
Sorry?
There is also a presentation on Saturday. So who will be here on Saturday?
Let me check.
It's
Let me
okay.
check. You will have Natale and Valentina on Saturday.
Okay.
Valentina, yeah.
Valentina. It's okay. Thank you so much, everybody. I see you tomorrow morning.
Yes.
Sure. Thanks, bro. Bye.
Thank you.
Tomorrow at 9.
Bye, Jamil.
Thank you. Bye.
Okay,
Bye.
bye.
Jenny. See you.
Goodbye.
Bye. Ciao.